For section 4.1, classifying triangles, we are going to start by looking at the 4 types of triangles that are given by angle measures. So the first one is an acute triangle, and that means it has 3 acute angles. And remember that an acute angle is less than 90 degrees. The second one is an equal angular triangle, and that means that all 3 angles are exactly the same. So those angles have to be 60 because the 3 of them have to equal 180. So in order for 3 of them to be the same, they all have to be 60 degrees. The third one is a right triangle, where one of the angles is a right angle, and a right angle, remember, is 90 degrees. And that is given by that little square there in the corner. And then the fourth one is obtuse. An obtuse triangle has one obtuse angle. And remember, an obtuse angle is larger than 90 degrees. So for example 1, we're going to start off by classifying each triangle by their angle measures. So the first one is triangle EHG. And EHG is the entire large triangle there. So if I start at E, that is a 30 degree. Then I go up to H, and that is labeled there with that red box, and that indicates that that is a 90 degree angle. And then G is 60. So I have a 30, a 90, and a 60. So if I go up here and look, they're not all acute because 90 degree angle in there. And they're not all congruent. And then the third one says one right angle, and there is a right angle in there. So this is a right triangle. EFH is the smaller one here on the left-hand side. And we can see that 2 of the angles are labeled with 30 degrees, and then the third angle is missing right here. So we can look at 2 things. We can add up the 2 that we know. So we know that they're 60 degrees. We also know that the 3 angles add up to be 180. And if we already have 60, then we're missing 120. The other thing that we can look at is these 2 angles make a straight line. So those 2 angles together make 180 degrees. And we know that this one on the right is 60. So 180 minus 60 is 120. So both ways prove that this angle is 120 degrees. So we have a 30, a 30, and a 120 degree angle. So if we go back up here and look, they're not all less than 90. They're not all congruent. There is not a right angle, but there is one obtuse angle. That 120 degrees is an obtuse angle. So this is called an obtuse triangle. And our last one is FHG. And FHG is this triangle over here on the right-hand side. And notice we have 60, 60, and then we don't know this top one. So if we add the 60 and 60 together, we get 120. 180 minus 120 is 60. So that proves that that is 60. Again, we could have looked at this entire angle, which we know is 90. And we know the smaller one over here on the left is 30. So 90 minus 30 is 60. So both ways prove that that is 60 degrees. And if you look, all 3 angles are 60 degrees, and which means they're all congruent, they're all the same. So this is an equal angular triangle. Oops, there's an I in there. And then moving on here, we are going to classify triangles by their side lengths. So if all 3 sides are congruent, it's an equilateral triangle. And that will be indicated by the 1 tick mark on all 3 sides. An isosceles triangle has at least two congruent sides, and that will be indicated also by tick marks on 2 of the 3 sides. And then a scalene triangle has no congruent sides, so none of the sides are the same length. So for this example, we have to classify each triangle by its side lengths. So the first one, we're going to look at A, B, C, which is the smaller one here on the left. And we can see that there's a tick mark here and here, which is indicating those two are the same. But if we go down here and look at the bottom, that one is also 15. So all 3 sides here are labeled 15 inches, units, whatever they are. So all 3 of them are the same, so that's an equilateral triangle. Then we have ABD. And ABD is the large triangle, the whole thing. And we have side lengths of 15 here. We have 18 over here, and this total here is 20. So none of those sides are the same. So if you go back up here to the chart, no congruent sides is a scalene triangle. And last one is ACD, and that is the little guy over here on the right-hand side. We've already figured out that that middle line going down is 15, and then we have 18 on the right-hand side and 5 at the bottom. And so that means that none of those are the same. So that is also a scalene triangle. Oops. And for example 3, we're given a triangle where the 3 sides are labeled, but not nicely. And we are asked to find the side lengths of the triangle. So we have to find all 3 of those sides. So what you want to look for is sides that are the same. So as you can see here, we have a tick mark here and here, indicating that those 2 are the exact same length. So what I know right now is that 4x minus 1.3 is the same as x plus 3.2. So I can go ahead and solve for x here in this equation that I just made. Remember, when we have variables on both sides, we want to move the smaller one. So I'm going to subtract x from both sides. So I have 3x minus 1.3 is equal to 3.2. And then I'm going to add this 1.3. So I have 3x equals 4.5. And then I have to divide both sides by 3. And 4.5 divided by 3 is 1.5. So now I know what x is, but now I can use that in all 3 sides to figure out our missing lengths. So here on this first side, I have x plus 3.2. So I have to do 1.5 plus 3.2. So this side is 4.7. Over here, I have to do 4 times 1.5 and then minus 1.3. And 4 times 1.5 is 6, and then we have to minus 1.3 from that, and we would get 4.7, and that's good because the tick marks showed us that that was the exact same. We should have gotten the same answer there. And then on the hypotenuse here, the longest side, we have to do 5 times 1.5 and then subtract 0.2. So 5 times 1.5 would be 7.5, and then subtracting 2/10 from that would give us 7.3. So this side is 7.3. So that completes our problem, finding all 3 side lengths. And then for our last example, we have a manufacturer produces musical triangles by bending pieces of steel into the shape of an equilateral triangle. The triangles are available in side lengths of 4 inches, 7 inches, and 10 inches. How many 4-inch triangles can the manufacturer produce from a 100-inch piece of steel? So we're thinking about an equilateral triangle where all the sides are 4 inches. So if I add that all up, I have 4 times 3. So they're going to need 12 inches for each triangle. And we have 100 inches. So I'm going to have to do 100 divided by 12. And when I do that, I get 8.3 repeating, which means that the manufacturer can only make 8 triangles out of that piece because that 0.3 repeating is not enough to make the 9th triangle. So our answer here is 8 triangles.